Guess who? All right, Math 8. Let's get this done. Okay, we're going to correct page 395, 1 through 7, just for a goof. Okay, now, remember you can always stop the video. Now let's go look at what we did here. Okay, the first one, we had A and B were 21 and 35. And they want us to find C. Who broke in and turned this into a green pen? That is wrong. Actually, we're finding A. No, let's call this, well, either way, I'm not sure which one I did here. Let's see. A was 21 and okay. It's been a long day. All right, so A is what we're finding. This is A, we already know B, and we know C. So we're finding A. Okay, helps when you know what the heck you're doing. So we plug in what we know, and we go, all right, B squared would be 21 squared, 441, and 35 squared, if I remember correctly, that's like 1225. The more you do it, the more you remember them. Now I got an equation that I have to solve. The 441 has to go, and the squared has to go. Okay, so I subtract 441 from both sides. These two go. I should have A squared equals 784. Oh, that's an easy one. Psych. All right, now I got to go to that table. And I got to say, all right, this number doesn't exist. This number doesn't exist. And I got to go 784 sits in between these two. So the left side should be 625, the right side should be 900, and 784 is somewhere in between 25 and 30, if it's a whole number. We can always do the check quickly to see if it's a whole number by squaring some stuff. And remember the shortcut, if it ends in 4, when you square 25, that ends in 5. When you square 26, that ends in 6. When you square 27, 7 times 7 is 49, it ends in 9. When you square 28, 8 times 8 is 64. That could be the one. Let's square 28 and see what we get. Beep-a-bop, beep-a-bop, 8, so 784, there we go, that's our answer. And if it's not a whole number, then you gotta start squaring some stuff, and that's not gonna be pretty. Okay. Let's take a look at the second one. Let's go back here first. Okay, so we know A and B and we're finding C. All right. Let's find C. So 16 squared, I remember that's 256 because 15 squared is 225. 30 squared is 900. Add them up, 1156. Uh-oh, that arrow tells me I gotta go to that table again. 1156, where does that sit? 1156 sits here. Look familiar? Okay. It's always going to be in between two of these, and hopefully it's going to be a whole number. So my left one is 900. The right side is going to be 1225, and then we say, all right, if it's a whole number, it's between 30 and 35. It's going to be one of these 4, one of these 5. Oops. Somebody put 35 on here. Sally! Okay. So it needs to end in 6 if it's a whole number. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, if we squared 34 and just really messed up the 4 again, like the last time I did a video here, square that, it ends in 6. And if you square the whole number, yep, 1156, that's what we're looking for. So it is a whole number, 1156. Perfect. All right, so that's the second one. Let's take a look at number 3. Oh, 3 through 6, they want to know whether each triangle with the given side lengths is a right triangle. Remember how if you don't see the box right here or here, if you don't see the box there, we don't know if it's a right triangle or not. And if they give you all 3 sides, you can say yes or no, it is or it isn't a right triangle. Let's go to number 3, and they gave us what? 11, 60, and 61. Okay. 11 squared, 121, 60 squared, 3600, 61 squared, I don't know, I'd have to write that one out and do it. And if you add them up, left side equals the right side, yes, that's a right triangle. For number 4, 9, 37, and 40. 9 squared is 81, 37 squared I have no idea, but 40 times 40 is 1600. If you square these, add them up, nope, left side doesn't equal the right side, not a right triangle. Remember, you can freeze this. I'm going to go a little quickly because I have a lot to do. Okay, number 5, we said 15, 35, and 38. Fifteen squared, 225, 35 squared, 1225, 38 squared, I have no idea. Some of the ones I've memorized, some of the ones like this, not on my table, I'm probably not going to memorize them. Do the math, add them up, nope, not a right triangle. For number 6, they had 28, 45, and 53. This one I should have memorized, but I'm trying to think. 50 times 50 is 2500. 40 times 40 is 16. I gotta memorize that one. Okay, so anyway, you square it, you square it, you square the last one. Left side equals the right side. Yes, that's a right triangle. Okay, for number 7. It says, Homegirl has a triangular shaped card. The lengths of the sides are 4.5, 6, and 7.5. Is the card a right triangle? Huh. Okay, so we're going to square all three parts. See how 45 squared is 2025? 4.5 squared, you come back 2 places. So if you had 45 squared memorized, you could do that one in your head because you're coming back 2 places and it's 20.25. 6 squared is 36. 75, I don't have in my head. Either way, so you get this done, add them up. Yes, it's a right triangle. Okay, that concludes the homework, but there were more problems on here. And for this one, it said, find the distance between the given points, round to the nearest, oh, sweet, fancy Moses, round to the nearest 10th. That can't be good. Okay, so what they're doing here is they're saying, find the distance between the given points A and B. Well, A and B, you could go this way and make a triangle, or you could go this way and make a triangle. I think I went top, like that. And I used the blue one. See the blue one here? Don't answer, I'm on a video. Okay, so I go up 1, 2, 3. So that side is 3. Here I go 1, 2, 3, 4, 5, 6. So that side is 6, and that's what I'm finding is C. Okay, so number 8 is way down here. Here comes the fun stuff. So we had A is 3, B is 6, square them both, add them up, not a right triangle, or not a perfect square. Uh-oh. What does that mean? Square root of 45. Let's go over here. Okay, this doesn't exist. I had these covered up and then I uncovered them. I was looking them over. Okay, so 45 sits in if I was looking at those and I go, there's going to be a perfect square on each side, I'm going to go 49, which is 7. And instead of coming down from 45, I'm going to go down 7, go down 1, that's going to be 6, square it, that's 36. Notice how this is the middle right here. I put the 45 closer to the 49 because if you look, 36 plus what is 49? 36 plus 13 is 49. 36 plus what is 45? 36 plus 9 is 45. So it's 9/13 of the way there. That's why usually I put the 45 about right there in the middle. This time I'm making it more realistic so you can see it's closer to 49. It's closer to 7 than it is to 6. So it's really 6 and 9/13 of the way there. If you made 9/13 into a decimal, 9 divided by 13, sometimes you get pretty close that way. But it doesn't always give you the answer. Remember, if we don't know for sure, okay, here's a shortcut that I want to show you, but I don't want to confuse you, but I've done it before, so it should look familiar. Okay, if it's 9/13, remember, half of 13 would be 6.5. Wouldn't 6.5 be half of 13? That's the exact half of 13. 9/13 is closer to 13/13. So I'd probably start squaring 6.6, 6.7, 6.8, and 45 is going to fall. Remember we did this? We did it the last assignment. Take 6.6 and square it, take 6.7 and square it, take 6.8 and square it. You're trying to get a guesstimate of where to start. And when you find whatever this is, 45 is going to be in between a couple of these, and whichever one it's closest to, that's going to be your answer. In this case, it was closer to 6.7. Not fun, not easy, but we've done this, so I'm just showing you guys this stuff, so when you see it again, every time you see it, it gets a little bit easier. Okay, let's go to number 9. Okay, so number 9, they're saying B and C. Okay, B and C, B and C is right there. You could go this way and make a triangle, or you could go here and make a triangle. Let's see what I did. There, the one in green. So what are the sides? The bottom is 1. This side is 7. Okay, and then you do the math. Take what we know and then find C. 1 squared is 1, 7 squared is 49, add them up, 50, square root of 50. Okay, come over here. Notice how I put the 50 really close to the 49. Erase, 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 erase. Okay, what's a perfect square that's close to 50? In my head, I'm going 49, which is 7. 7, the next one up is 8. 8 squared is 64. Well, from 49 all the way to 64, that's plus 15. From 49 to 50, that's plus 1. So it's really 7 and 1/15. It's 1/15 of the way there. 49 is right next door to 50. 50 is right there. So it's 1 1/15. 1/15, that sure looks like it's going to be like rounded up to 0.1. So I'd probably take 7.1 squared, 7.2 squared, and 50 is going to sit in between those two. And it's closer to 7.1. If I didn't have 8 million things to do here, I'd go back and I'd do the math on those. Okay, let's see number 10. Okay, find the distance between A and C. Okay, A and C is here, and I could do the triangle this way, probably the easiest way since I go off the graph here. So there's A, B, and C, and it's the red one. Well, this is going to be 1, 2, 3, 4, and this one's going to be 1, 2, 3, 4, 5. So A is 4, B is 5, we're finding C. Okay, so take A, 4, square it, take B, which is 5, square it, 25, and 16 is 41. Not a perfect square. Oh, geez, here we go. Okay. Not there, not there. Okay, the square root of 41 sits in between what? I know the 49 is 7. What's to the left? 36? Let's go 36, just for a goof, which is 6. The next consecutive integer is 7. In this case, whole number is 7. Square it, 49. So 41 sits in between those two numbers. From 36 to 49 is plus 13. From 36 to 41 is plus 5. So it's 6 and 5/13 of the way. Remember we said 6 1/2 is half of 13. 5 is not going to be halfway, it's going to be less than halfway. I might take 6.4 and square it, 6.5 and square it, and see which one it's closest to. 6.4 squared, 6.5 squared, and see if 41 sits in between these two, and it does. It sits closer to 6.4. Okay, let's take a look at number 11. How can you use the Pythagorean theorem to solve real-world problems? You can use the Pythagorean theorem to find missing lengths in objects that are right triangles. Write that down. Remember, you got to look this stuff over. I don't want to use a bad word, but I'll use it today. Study. Okay, let's go to page 389 through 391. I told you guys I was going to go over it again. Just for a goof. It says, how can you use the Pythagorean theorem to find distance between 2 points on a coordinate plane? Well, on a coordinate plane, it's easy. The vertical piece is 4. The horizontal piece is 2. Find the hypotenuse. That's easy. The problem is, now we're going to do your turn, number 1. So, as long as you have a grid here and you have these numbers here, as long as you have these numbers here to tell you how far each box goes, if that box is 3, this is 1, this is 2, and this is 3. It's going up 1, up 2, etc. Now I can do it easily. I can go, all right, how far is this? 1, 2, 3, 4, 5. The horizontal piece is 5. The vertical piece is 1, 2, 3, 4. So I've got A is 5, B is 4, or you can switch those two, and then C is we're going to find. And if you did the math, square it, square root of 41, that looks familiar. Came up with 6.4. We did all this stuff, remember? Just did that one a few minutes ago. Okay, but here's the problem. Remember, if you have the grid, you're good. You can figure it out. Find C. But if you don't have the grid, now what? You don't have the boxes, the grid. But you've got this, you can still do it. They still go up by 1 or down by 1. You could count from here to here, 1, 2, 3, 4, 5, and 1, 2, 3, 4. You can still do it. What if they give you this situation? Now what are you going to do? There's no grid and there's no numbers. From 0 to here could be 6.7. It could be 0.2. It could be 5,000. We don't know. So that one, I don't see how I'm solving that one. But if they gave me this, the coordinates, now I can figure it out. If I want to find this horizontal piece here, from this dot all the way to here, the x is changing. It's a number line. It's a horizontal number line. What's changing? The x. The height, the y, stays the same. Always got to erase stuff that I don't want to erase. Okay. So see how the y, the blue arrow there tells you the y stays the same. See how the y is 2 and the y is 2? I'm crossing them out. How do I get from -3 to +2? If you had a number line, just count them. 1, 2, 3, 4, 5. So it's still 5. And if you're checking out the y here, you're going vertically right here. You want to find this side. The x is not changing. The x, see the blue arrows? The x is staying the same. This dot and this dot are the same distance from 0. But the vertical piece is what we're finding. We don't know that it's 4. So x stays the same. They're both 2. We're not looking at that, so I'm crossing them out. From 2 to -2 on a number line is 4. 1, 2, 3, 4. And if you're adding if you're adding or subtracting, you get a negative number, it's not going to be a negative distance. How long's your yard? It's -60 feet. Really? I don't think it is. It's got to be positive. So use the x or the y, whichever one's changing, to find out what the coordinates are, and you go, oh look, 5, 4, right back where we were. Okay, let's go to page 391. Okay, same thing here. Finding distance between 2 points. The Pythagorean theorem can be used to find the distance between 2 points in a real-world situation. You can do this by using a coordinate grid that overlays a diagram of the real world. I don't see a coordinate grid on here. Looks like a bear. The head's over here. Mouth is there. I don't know, maybe a seal? I don't know. No, a seal wouldn't body like that. Okay, anyway, so same thing here. We don't have the grid. We don't have any numbering here except for we have the coordinates of each vertex. That will enable us to find what we need. So let's see what she's doing. Let's see, Francesca, aka homegirl, wants to find the distance between her house on one side of a lake and the beach on the other side. She marks off a third point, which is the hypotenuse here, forming a right triangle as shown. The distances in the diagram are measured in meters. Or as they say in Holland, meters. Okay. Use the Pythagorean theorem to find the straight line distance from Francesca's house to the beach. Okay, find the length of the horizontal leg. Okay. Notice it's not going up or down, it's going left to right. Up or down is the y. Get rid of it. You could say from 10 to 280 is 280 minus 10, 270. And now we're finding the vertical piece. We don't need the x because the x stays the same. This dot and this dot are both 280. See how they're both, the x's are 280? Don't answer, I'm on video. Okay, you want to find the y? Find the difference between 164 and 120, which is 144. Now you can solve it. Big numbers. And they talk about absolute value because if you subtracted down here and you went 10 minus 280, you'd get negative 270, but it can't be a negative distance, so they say take the absolute value just in case. Okay, then you got the Pythagorean theorem, and you square it. You square it. Big numbers. Calculator, square root, 306. If they gave me $100, I'd find it without the calculator, but it would take me a while. Okay, the distance from her house to the beach is 306 meters. Okay, that's as simple as popping a pimple, except for the simple part. Okay, so for homework, it's a quiz, but you're at home, so it's the homework really. This will not hurt your grade, it's only going to help. Treat it like a homework assignment. You got 1, 2, 3, 4, 5. You might run out of room on there. I'm going to send you a copy of this. These are yes or no. Yes or no. Or you could put triangle or not a triangle. And here they want you to find, use the Pythagorean theorem. This should look like something we've done. Don't stress. Think of it as a homework assignment. Do your best. And we'll see you next time.